Okay, so now we're in chapter 10.2 and we're dealing with rational exponents, which means we have fractions in our powers, and the same rules that we learned from Math 101 apply to these same exponents even though they're fractions. So let's start by looking at number 16. It says use radical notation to rewrite each expression. And it has 5xy raised to the 1/3 power. Okay, well, if we think back to the properties we learned, we know that we have, one second, let me change my color. The nth root of a is the same as saying a raised to the 1/n power. So whatever number is in the bottom, basically in my denominator of my fraction, the 3 determines which root I'm dealing with. So this is going to become the cube root of, and then whatever's inside parentheses is written underneath the radical, the cube root of 5xy. Alright, now let's look at number 20. And it says, rewrite each expression with rational exponents. So now they want the fractions in my power. So I want to go from the radical to the fraction powers. So I have parentheses, the cube root of 19xy, all raised to the 5th power. Okay? Alright, so let's talk about another property that we learned. We learned that if we have the nth root of a all raised to the nth power is the same as saying a raised to the m divided by n power. So again, the number that represents the root, n, is on the bottom of the fraction. So the number that represents the root is 3, which means the 5 must be on the top. And what's inside the parentheses? 19xy. And make sure you're using, inside the radical is 19xy. And make sure you're using parentheses because it's all of this being raised to the 5/3 power. So again, let's do that again. 3 is the root, so he is at the bottom of the fraction. 19xy is inside the radical, so he's inside the parentheses, which means automatically 5 is going to go on the top. So it's 19xy all raised to the 5/3 power. Alright, number 22. Rewrite each expression with a positive rational exponent. So all of your exponents from here on out have to be positive. So I have 3x times AB all raised to the -4/5 power. -4/5 power. Okay, another property we learned was if we have a negative exponent and we want to make it positive, you take the base being raised to that exponent and you move it from the top to the bottom and the power automatically comes positive. Or you move it from the bottom to the top and again the power automatically becomes positive. So something like a raised to the -m/n power is the same as saying 1/a raised to the m/n power. The base is a, so you move the base from the top to the bottom and the power automatically becomes positive. And another one was 1/a to the -m/n power is the same as saying a raised to the m/n power. Who's being raised to the negative power? Well, it's a, so you go from the bottom to the top, which means your power goes from negative to positive. So this one, who's being raised to the -4/5? Just this piece. Therefore, the 3x has positive power. You just leave it alone. It stays on the top. The only piece that goes to the bottom is this right here. And what's the base? AB. So AB is now raised to the +4/5 power. Great. Now we're going to move on to number 23. And what do we got here? Use properties of rational exponents to simplify each expression. So x to the 1/3 power times x to the 1/4 power. Well, the rule is if I'm multiplying like bases, so I'm multiplying like bases, you must keep the base and add the exponents. A neat way to remember it, if you are multiplying here, you must add here. It's the opposite. Multiply, add. Multiply, add. A lot of us get confused and we always want to multiply up here. But if you're multiplying down here, do the opposite, you must add. That might be a good way for you to remember it. So if you're multiplying like bases, keep the base, which is x, and then add the exponents. So it becomes x to the 7 over 12th power. Right? Alright, number 27. We use rational exponents to simplify each expression. If rational exponents appear after simplifying, write your answer in radical notation. So basically I'm simplifying and my final answer needs to be written with some kind of square root, cube root, or nth root kind of thing, a radical. So I have the cube root of x to the 9th, y to the 12th. So basically, you start your answer with a radical, use fraction powers to simplify it, and then you write it back as a radical. That's what they want you to do. Alright, so let's look at this. So what I would like us to do is, if I always look at whatever this root is. This is the cube root, so everything inside here has to be written as something raised to the 3rd power. Something raised to the 3rd power. So x to the 9th is like saying x to the 3rd power raised to the 3rd power. The best way to do this is always do the power inside divided by the power outside. 9 divided by 3 is what? 3. That's how you get that 3 right there. And then you have y, something y has to be raised to the 3rd power. Well, what is it? 4. And a good way to check, 3 times 3 is 9. 4 times 3 is 12. Okay, and what do we know is going to happen with our 3rd power and our 3rd root? Cancel and cancel. And I have x to the 3rd, y to the 4th. Good. Number 30. We have the cube root of x squared divided by the 4th root of x squared. Alright, well, first thing first, I cannot put them together because they are not the same root. Therefore, I must find a way to rewrite this problem. So let's start here. They're both x to the square, right? So let's see here. Let's get a different color. They're both x to the square. So I'm sorry, when I say they're both, I mean the argument is x squared. So I got x squared. The root here, matter of fact, let's start from the very beginning. Let's write everything down. Let's start by rewriting the radical using fraction powers. So who's inside the radical? X squared. Make sure you put parentheses around it. And what power is it being raised to? The 1/3. Remember, the property, the nth root of a is the same as a to the 1 over n. And then do the same for the bottom. X squared. And raised to the 1 over 4 power. Good. Now remember, if you have like bases, so these are like bases, right? They're both x squared. So the rule is keep the base. So keep the base. And then and since I'm dividing, what do? We subtract the exponents. My pen is messing up. Okay, so keep the base, subtract the exponents. 1/3 minus the 4th is the same as saying x squared raised to the 1/12. Good. Alright, and then the last thing we need to do, remember the rule, when it's power to power, you multiply. So that's x to the 2 times a half. Keep the base, multiply the powers, and you get x to the 1/6, which is the same as saying the 6th root of x. Okay, that's chapter 10.2. Let me know if you have any questions.